Hey guys, Mrs. Foster here. I just wanted to go through and talk about the expectations for day 4 of Unit 9A. So I'll go ahead and share my screen here and we'll just kind of go through quick warm up, quick review, and then I'll get to the expectations for today. Alrighty, there we go. All right, so first of all, our warm up for today, we've been talking about standard form a lot of quadratic functions. And part of graphing in standard form is being able to evaluate functions and find points for a quadratic function. So that's what we're going to start with today. So all we're going to do is we're going to substitute different values of x into the given function. Now, a lot of times when we're looking at standard form, instead of f of x, we'll have it written with a y. Y equals 3x squared minus 2x minus 8. Same idea as when we have f of x. We talked about this on day 1, so don't let that really throw you off. Same idea. It's just talking about inputs, our x values, for our outputs, either f of x or y. So in this case, we're going to substitute in our x value and see what we get out for our y value, or our f of x. So I would encourage you to pause the video, try these 3 on your own, and then press play and see if we end up getting the same thing here. All right, so to start off, if I have x equals 2, all I'm going to do is I'm going to rewrite my original equation, 3x squared, and you'll notice that I'm leaving a little blank there with my parentheses because we're substituting a value in for x. So instead of x, I'm going to use 2. That's what they told me x is, so I'll just put a 2 in place of wherever I had an x. Now we're just going to follow order of operations to simplify. So to start with, let's square our x value, which is 2. So 2 squared is 4. So I'm going to have 3 times 4 minus 2 times 2. Still didn't change anything here, and minus 8. The only thing we did is squared our 2 value. Okay, moving on. Next thing we're going to have to do is we're going to have to multiply. We need to multiply before we can add or subtract. So we'll multiply 3 times 4. That's 12. And I'm going to multiply negative 2 times 2, which is negative 4. My minus 8 stayed the same. Well, now I'm just subtracting here. 12 minus 4 minus 8. So if I go left to right, 12 minus 4 is 8. 8 minus 8 is 0. If this part starts throwing you off with integers, don't be afraid to just use your calculator for that too. That's totally fine if that's how you need to simplify integers and solving integers at this point. So the way that we can write out our answer now is when I had f of 2, when I put 2 in place of x, I got out 0. That's the first one. If you needed to follow along with me for the first one, that's fine. Why don't you go ahead and pause the video now and try out the next 2. All right, I'm going to flip my color a little bit here, but first we'll do the same thing, exact same thing as before, same equation. We're just changing our x value. So I'll rewrite it just like this. Put in this time we have negative 1. So negative 1 here, negative 1 here. So I've got 3 times negative 1 squared, which is positive 1, minus 2 times negative 1 minus 8. All right, same thing as before. We're going to go through and we're going to multiply now. 3 times 1 is positive 3. Negative 2 times negative 1 is a positive 2. And my minus 8 stays as it is. So I got 3 plus 2, which is 5. 5 minus 8 is negative 3. And if you needed to put that in a calculator, that is a-okay. So we got f of, I put in a value of negative 1, and I got out the value of negative 3. Last one here, I have x equals 0. So I've got 3, again, times what we're going to put in for x squared, minus 2 times what we're going to put in for x, minus 8. And this time I'm going to put in 0. So I've got 0 squared, which is 0. And I got minus 2 times 0, that hasn't changed, and minus 8. So we got 3 times 0, which is 0, minus 2 times 0, which is 0, minus 8. 0 minus 0 minus 8 is negative 8. So when I put in my last function of f of 0, I got out negative 8. Now, if we wanted to write these as ordered pairs, so like what we'd be using for standard form, then you just write it as your x value, comma, your y value. Your input is your x value, your output is your y value. So when we put in 2, we got out 0. So I have the point 2, 0. When I put in the point -1, I got out -3. When I put in the point 0, I got out -8. So if I wanted to, we're not going to do that right now, but if I wanted to graph this original function right here, then I know the point 2, 0, -1, -3, and 0, -8 would all be a part of that parabola. All right, so like I said, last week we were talking about graphing a quadratic equation in different forms, standard form, vertex form, factored form. We've talked all about those different forms, the 2 things that you can tell from each of those forms. Today in this quick little review, we are just going to focus on standard form. So let's take a look and see what we already talked about here. We'll just kind of go through our order of graphing in standard form. First of all, let's review standard form. Y equals ax squared plus bx plus c. And remember, when we are graphing in standard form, or when we're given any quadratic in standard form, we can tell 2 things right away just by looking at the equation. We know what our concavity is based off of our a value, whether it's concave up or concave down. And we know what our y-intercept is based off of our c value. Now, when we're graphing, we talked about this last week, the first step of graphing is finding the axis of symmetry. And to find the axis of symmetry, we use this specific equation. It's -b, so -b, this is our b value, divided by 2 times your a value, whatever a is. So that's how you're going to find your axis of symmetry. And the axis of symmetry is a vertical line. Sorry, we have an equation here instead of just a number. Vertical line x equals, and it splits the parabola directly in half. Now, after you find your axis of symmetry, you're going to use that x value, whatever you got for x there, you're going to substitute it into the equation just like we did in our warm-up to find your vertex, to get the y value for the vertex. So you'll get an x and a y, and that should lie on your axis of symmetry. Once you do that, then you can go ahead and identify your y-intercept just by looking at your equation given you in standard form. It's always going to be your c value. And if it fits on your graph, go ahead and graph that point. Get yourself a second point on the graph. The nice thing is, using our axis of symmetry, we're then able to reflect over the axis of symmetry to find another point off of that y-intercept. Once again, if it fit on the graph. If it doesn't, then we'll just go down to our 5th step, which is choose another value for x. So this is any value that you want to choose for x, and you can be specific about this. But when we are looking at our warm-up, I gave you values. I gave you 2, I gave you -1, I gave you 0. I'm not always going to give you values, or you're not always going to be given values when you're trying to graph an equation. So it's up to you to pick those values and see if those are going to be helpful to you while you're creating your graph. If it gets really, really big, or really, really small, or if you get a weird number or a fraction, it might be kind of hard to graph it just by hand. So you got to be strategic about the numbers that you're choosing. Once you do find your x and your y value for your next point, you can just reflect that point, and that way you have 5 points to make a really nice looking graph. We're going to go ahead and put those steps into action right here, right now. So let's see. First step, we said find the axis of symmetry. So finding the axis of symmetry, we're going to use our equation -b over 2a. Now we'll look at this. My a value is 1. My b value is -2. And my c value is -3. So let's go ahead and I'll go back to a single page while we calculate this axis of symmetry. We're going to do -b, so -2 all over 2 times my a value, which is 1. So -2, where the opposite of -2 is a +2. 2 times 1 is 2. So I have 2 divided by 2, which is 1. So my axis of symmetry is x equals 1. I can go ahead and graph that line now. So at x equals 1 right here, we're going to go ahead and just put a dotted line. Now this line is not actually part of my parabola, but it helps me graph my parabola. All right, we're going to take that value that we found for our axis of symmetry, and step number 2 here says calculate and graph the vertex by substituting your x value in from the axis of symmetry into your original equation. So our equation up at the top, y equals x squared minus 2x minus 3. We're going to put 1 in for x, just like we did in our warm-up today. So I've got my original equation, 2 times whatever x is, minus 3, and I'll just substitute in 1. 1 squared is 1. 2 times 1 is 2. And then I'm subtracting 3. So I've got 1 minus 2 minus 3 equals negative 4. So my vertex is 0.1, negative 4. My x value tells me how far to the left or the right I'm going to go. So I'm going to go 1 point to the right. And I'm going to go down 4 because my y value, negative 4, tells me up and down. So 2, 3, 4. That's where I'm looking to put the point for my vertex. So I'm at 0.1, negative 4, right there. All right, next step, step number 3. We need to identify and graph the y-intercept if it fits on the graph. Let's see if it does in this case. My c is my y-intercept, which is negative 3. So it does fit on the graph here. So my y-intercept is just negative 3. My x value is always 0 though. So it's going to be just right here. The left to right 0, so I just go straight down. That's my y-intercept. Now we can reflect, like I said earlier, we're going to reflect over the axis of symmetry. So my y-intercept is 1 point away from the axis of symmetry, so I can go 1 point in the opposite direction, and I will get that point right there then. And it looks like my next point is at 2, negative 3. As we just reflected. Now this last 2 points, we're going to choose a value for x and calculate the value for y. This is step number 5. So once we get our value for x, we figure out what y is, then we can just reflect that, and that will get us our 5th point. So to get our 4th point, we'll go ahead and pick something. And I like to try to pick a number that's going to be close. You can already kind of see how I've got a parabola kind of forming there. My base at negative 4, and it's kind of opening up. We knew it was going to be concave up because we had a equals a positive 1. So I'm going to look for a number that's probably close for my x value to positive 1. Because it's going to be just a little bit to the left, a little bit to the right of that. If I get too much bigger, if I'm picking 8, 9, 10, negative 8, negative 9, negative 10, it's going to get really, really big, and it's going to be a hard number to graph. So instead, let's pick a number pretty close. So I've already got my value for x equals 2. So let's go ahead and try x equals 3. So just like we did before, we're just going to substitute it in to our original equation here. So wherever I had x, I'll put a 3. 3 squared, or 3 times 3 is 9. 2 times 3 is 6. So I've got 9 minus 6 minus 3, which gives me 0. So my point here, when I substitute in x for 3 and I get out 0, happened to be this time that I was actually able to find my 0 on my graph, or my x-intercept, or root. Another way to say that. You won't always guess the correct value for x, but just a little warning that when you're graphing on Delta Math, even if you don't find that 0 value, it wants you to graph 0, what your zeros. So after you find your 5 points, move one of your points back to the 0, just so Delta Math in the instructions, when it tells you to graph those zeros, you have them there. All right, last thing we have to do is we're going to reflect it. So we've got 2 away from my axis of symmetry to the right, so we'll go 2 to the left. And that's how I'm going to get my last point right here. Looks like it's at negative 1, 0, which is my other root. Negative 1, 0, my other root. Very nice. So then that's it. Last thing we have to do is we're just going to connect our dots and kind of make this nice little U shape that you see already starting to form here. Kind of coming up in this direction, and there we go. That is the function y equals x squared minus 2x minus 3 as a graph. Good job. All right, now like I said, I'm going to talk to you about kind of the expectations for today. It looks a little bit different because we are doing a little bit of a checkup, catch-up day to get you guys ready for a Unit 9A test that's going to be next week. So when we're looking at this here, you'll notice a couple of things that have been attached to Google Classroom. So first of all, you'll find this video attached there. Second of all, you'll find a checklist. So this checklist should look very similar to the one you see on the board here, except you won't have the stars on it. And your job is to go through and put either an X or a little mark. You can put your name, or you can write done, whatever you want, into each of the boxes for the assignments that you have done. So first of all, we have Unit 9A, the Desmos exploration. So if you have that done and you got credit for it, then you can go ahead and put a little X in there. If you haven't gotten credit for it yet and you finished it, make sure that you uploaded your work to Google Classroom on that day one Google Classroom post. Once you're done with that, then you'll move on to the Unit 9A Day 1 Delta Math homework assignment. Make sure that's done 100%, has to be 100% or you don't get credit for it. Following that, your Day 2, and then your Day 3. So those are all of the homework assignments from last week and the week before that. Once you're finished with that, that's when you move on to the Day 4 check-in. Now that is also attached to the Google Classroom post for today, is 2 problems that you'll be graphing. The tables are already filled out. The tables are there, so you can fill them out on a Google form and have that uploaded to the post once you're done. You do need to do those 2 problems because those are the first 2 questions on today's, the Day 4 homework assignment. So you'll notice when you click on your Day 4 homework assignment, see, I'll just show you guys really quick here. All right, I'll show you guys. Let's see. Day 4. All right, just gotta show my page to you. Okay, here we go right here. So you'll notice that it has enter the coordinates from graph number 1 on your handout. So on your handout, you would have already done this, and all you have to do is put in the values for the work that you already did. That's for the first 2 problems. So make sure that you're getting that done. That post is going to be on Google Classroom, and then you're just filling out the values that you already graphed on your handout, or if you printed it off on the worksheet there. So that's all that is for you. Once you're done with that, then you're just going to continue on working on your Unit 9A Day 4 review part 1. After you finish the part 1, you're done. That's it. Then you are all caught up. You know that you have days 1 through 4 done. You can relax. If you have any questions on any of the homework assignments, any of the problems, make sure that you're emailing me, reaching out to me so that I can get you some help and help you figure out where we're at with it. We are not completely done with homework assignments for this unit. When we come back the next day, I see you guys, will be Day 5. You'll have review part 2. So we're doing the graphing review on part 1, and then the rest of our learning targets will be reviewed on part 2. And then we'll be taking tests next time we meet. So technically Day 6 of Unit 9A will be the test day. So that's what I have for you. Make sure that you're getting this stuff done, uploading it to Google Classroom. So you have 2 different things that are linked on Google Classroom that you should be filling out, that Unit 9A Day 4 check-in and the actual checklist for all of your assignments, making sure that you are on top of things and that you are keeping up to date with your Unit 9A. Like I said, if you have questions, send me an email, but that's all I got. All right, guys, make the most of today. Do your best. I'll see you later.